Welcome, this is Amanda Rockinson's AppQ, and in this tutorial we are going to talk about descriptive statistics. This is part one of a two-part tutorial. In part one, we are going to identify and define distributions, measures of central tendency, dispersion, and also briefly look at how to calculate descriptive statistics in SPSS, as well as how to report them in APA format. Let's get started. The concept of distribution is foundational to everything we are going to talk about in this tutorial, and it's very foundational to statistics. A distribution is a list of scores taken on a particular variable. For example, the following is a distribution of 10 students' scores on a statistics test. Arranged from highest to lowest, you'll see that the distribution includes 69, 77, 77, 77, 84, 85, 85, 87, 92, and 98. A researcher can take a distribution and calculate measures of central tendency. There are three measures of central tendency, and you see them listed here: the mean, median, and mode. The mean is the arithmetic average of a group of scores, or it's the sum of scores divided by the number of scores. For example, in our distribution of 10 scores, we add 69 plus 77 plus 77 plus 77 plus 84 plus 85 plus 85 plus 87 plus 92 plus 98. And we divide that by the number of scores, which is 10, and we find that the mean is 83.1. Now, the median is the middle of all the scores in the distribution when they are arranged from highest to lowest. It's the midpoint of the distribution when the distribution has an odd number of scores, or the number is halfway between the middle or two middle scores when the distribution is an even number. So here, for example, we arrange our distribution of 10 test scores from lowest to highest, and we see that the median is 84.5. Finally, we have the mode. The mode is the value with the greatest frequency in the distribution. So here, for example, in our distribution, we see that 77 is the mode because it's listed most frequently. It's listed 3 times in this distribution. So in statistics, the measure of central tendency that's reported by the researcher depends upon the type of data as well as the distribution of the data. Let's talk about this. For categorical scores, the researcher would report the mode, the score that occurs most frequently, to indicate what response is most typical. For ordinal data or ordinal scores, the researcher would use the median. And for interval ratio level scores, quantitative data, the researcher would use the mean. However, sometimes the researcher would also report the median to describe central tendency. And he or she would do this in cases where there may be outliers or the distribution of data is skewed in some manner, because the mean is really less robust in cases like this, and actually the median may then be more useful. We're going to look at an example of this so that we can better understand it. However, before we do that, let's talk a little bit about variation. Now, variation occurs in every distribution. Before we define more specifically variance, let's talk a little bit about what it is and why it exists. I want you to think for a moment. If we look at students' course points in one online statistics course, it's likely that if we had 20 students, all of their course points would differ. Why would this be? Well, maybe some students have had more exposure to statistics than others. Maybe some have put in more time studying. These are variables that cause variation, and the reason that we have what we consider the range in scores. Why, let's say if the course points ranged from anywhere from 0 to 1,000, that's why we would have scores ranging anywhere from, let's say, 700 to 1,000. Let's look at another example. Let's say that we measure everyone in the class's heart rate. Again, the score values would differ across all of the class members. Why do you think that the heart rates would differ? Well, there's lots of reasons heart rates would differ. Variables that might cause different heart rates or cause variation in heart rate across class members may include things such as sex, age, body weight. Maybe somebody is drinking a cup of coffee or even just thinking about statistics. Maybe somebody recently exercised, so on and so forth. Again, these are variables that cause variation. It's the reason that we have the range of scores. Why then is understanding this variation or this dispersion of scores or the distribution important? Without knowing something about how the data is dispersed or how it varies, measures of central tendency can actually be misleading. Let's say that we know that socioeconomic status influences course grades. So, a researcher wants to know the socioeconomic status of a group of 10 students, the group of 10 students that we've been talking about. These 10 students, let's say, come from families in which the mean income is $200,000, with very little variation from the mean, meaning that most of the students come from families that make around $200,000. However, this would be very different if we had a group of 20 students who came from families in which the mean score was $20,000 also. But what we knew about these group of students is that three of the students' parents or three of the students come from families that make a combined income of $1 million, and the other students come from families that make a combined income of $60,000. Measures thus of dispersion provide a more complete picture of the data set here. So dispersion includes three measures. It includes range, variance, and standard deviation, and we're going to talk about those next. But before we move on and talk about those, I want to point out that this example also provides a good example of how the mean can be deceiving when there are outliers. In our second scenario, we have three outliers, the students who come from families that make $1 million. Really what we see is the majority of the families have a combined income of $60,000. Our median here is then $60,000 and really provides a better picture of central tendency than the mean does in this second scenario. We are now going to look at the measures of dispersion: range, variance, and standard deviation. Let's start with range. I've already talked about range, so you may have an idea of what range is, but the range is the distance between the minimum score and the maximum score. For example, in our distribution of 10 test scores, the range would be 29. Because our highest test score was 98, our lowest was 69, and 98 minus 69 is 29. Now let's talk about variance. The variance tells us about the variation of the data, and it's actually foundational to the next term we're going to talk about, which is standard deviation. Variance is defined as the average of the squared differences from the mean. Let's talk about how to calculate variance so we can better understand this definition. To calculate variance, the first thing that you need to do is calculate the mean. We've already done that. We know it's 83.1. Next, for each number in the distribution, subtract the mean. For example, we have the score of 98. We would take 98 minus 83.1. For the score of 92, we take 92 minus 83.1, and so on. Then we square that number, or each of those numbers, and that's known as the squared difference. Finally, we calculate the average of the squared difference. That is, we add up the squared difference and we divide them by the number of scores, which is 10. When we do this, what we get is 70.54. So the variance for the distribution that we've been looking at is 70.54. That brings me finally to standard deviation. Standard deviation is a commonly used measure of dispersion, and it's simply the square root of the variance. Here we know the square root of the variance of 70.54 is 8.39. Let's talk a little bit more about standard deviation. Because this is a really important term, and it's also a measure that's used in a lot of statistics that we're going to talk about in other tutorials. Standard deviation then is a measure, as I said, of the dispersion of scores, and it measures the dispersion of scores specifically around the mean. In other words, another way to think about standard deviation is how spread out a set of numbers are, or how far numbers are from what's normal or what's average. The larger the standard deviation, then, the larger the spread of scores around the mean. And the smaller the standard deviation, the smaller the spread of scores is going to be around the mean. Let's talk a little bit further about standard deviation and look at it in terms of a normal bell curve. Here we have a picture of a normal bell curve, and for normally distributed data values, here we can see that approximately 68% of the distribution falls within one standard deviation of the mean. 95% of the distribution falls within two standard deviations of the mean, and 99.7% of the distribution falls within three standard deviations of the mean. Now let's talk about this in terms of the distribution that we've been looking at. If our 10 scores were evenly distributed with the mean of 83.1, this would mean that 68% of our scores would fall between 91.49 and 74.71. Now, before we go on, how did I get that number? Well, let's talk about 91.49. What I did was I knew that our mean was 83.1, and if I add our standard deviation of 8.39, what I find is that the first standard, or scores that are one standard deviation above the mean, are 91 or equals 91.49. Then if I take our mean again of 83.1 and I want to know scores that fall below one standard deviation of the mean, or a score that falls below one standard deviation of the mean, I'm going to find that if I take 83.1 minus 8.39, that I'm going to get 74.71. Okay, so that's how I'm getting those numbers. So let's go back. So if our 10 scores, again, were evenly distributed with the mean of 83.1, we would know then that 68% of our scores would fall within one standard deviation of the mean. That means our scores would fall between 91.49 and 74.71. Then we would also know that 95% of our scores would range between 99.88 and 66.32, and then finally 99.7% of our scores would fall between 108.27 and 57.93. Now that we've defined measures of central tendency and also measures of dispersion, we're going to take a little bit closer look at measures of dispersion just to make sure that we have a clear understanding of them. We're going to walk through this example and calculate variance and standard deviation. While I'm aware that software such as SPSS automatically calculates these values for you, you still need to understand the statistic and how it works and be able to know how to calculate it, because this will really help you understand what the values represent so that you can clearly describe and interpret them when you get them in the SPSS output. So let's take a look at this example. An educational statistics professor has a class of 5 students. The students' course points range from 0 to 600. And the following are the students' points. There's a student that has 600 points, a student that has 470 points, a student that has 170 points, a student that has 430 points, and a student that has 100 points. Now remember that variance is foundational to standard deviation, so we first need to calculate the variance. The first step to calculating the variance is to calculate the mean. And remember, we calculate the mean by adding all of the scores and dividing it by the number of scores, as you can see I've done here. Here we find that the mean is 394. For each number in the distribution, we then subtract the mean. And here you can see all of the numbers with the mean subtracted. For example, 600 minus 374 equals 206, and so on and so forth. Once those numbers are calculated, we then square those numbers. Remember, those numbers are known as square difference or square differences. We then add the square differences and divide them by the number of scores. In this case, remember, we have 5. And by doing this, we find that the variance is 21,704. Now that we know the variance, we can calculate the standard deviation. The standard deviation, remember, is the square root of the variance. Here, the square root of 21,704 is 147.32, or rounded 147. So our standard deviation in this example is 147. Now that we know the standard deviation as well as the variance, we as educational researchers or social science researchers can use the standard deviation to determine which scores are within one standard deviation of the mean. Here again, I've listed, just as a reminder, the distribution of scores. We know that the mean is 394 and the standard deviation is 147. So how do we use these scores? Well, scores between 220 and 541 fall within one standard deviation of the mean. Again, in order to find the 220, one standard deviation below the mean, we take 394 and we subtract 147, which is the mean minus the standard deviation. And then in order to calculate one standard deviation above the mean, we take 394 plus 147 and we find 541. So again, we know that the scores that range between 220 and 541 fall within one standard deviation of the mean. And what we can see if we look at our distribution is that we have 3 scores that fall within one standard deviation of the mean. We can also note, if we look at our distribution, that one of the students is a really high achiever with a score of 600, whereas one of the students is somewhat of a low achiever with a score of 170. Before we move on from this example, I want to discuss 2 more important points. You'll note that the formula that we used to calculate both variance and standard deviation assumed that we were using a population of 5 students. So what we did when we calculated variance is we divided by n, or 5 in this case. However, if the data was from a sample, for example, let's say that we had 10 students in the class and we randomly selected 5 of them, we would have divided by n minus 1, or 5 minus 1, which would be 4, when calculating the variance. So if we did this, what we would find is that our sample variance was 27,130 and our standard deviation was 164. So this is just an important point to note, that the population formula here is different from the sample population formula, and you'll find that to be the case or to be true in a number of the statistics we'll discuss in these tutorials. I then also wanted to take time to refer back to a point that I made earlier. Remember when defining standard deviation, I said that the larger the standard deviation, the larger the spread of scores around the mean and each other. Here we have an example of 3 distributions. You'll first see at the top the distribution that we've been talking about, where the mean is 394 and the standard deviation is 147, with our scores ranging from 170 to 600. Let's say that we took another sample of score, we looked at another sample of scores, and this distribution ranged from 70 to 600. So the range is a little bit larger. What we see here then is that the mean is 334, so it's a little bit lower. and that our standard deviation is 236.07. What we notice that the lower score of 70 influenced the mean, and we also can note a larger standard deviation, which implies, which we can see by examining the scores and which we talked about, is that the scores are more spread out. Let's say then we have one more, we take data from one more sample population. And this this distribution is not as spread out. The range is only from 370 to 600. And what we find is that the mean is 454 and the standard deviation is 89.61. In this case, what we see is that the mean is smaller, but larger in this case, because the scores are higher. However, we then see that the standard deviation is smaller, implying that these scores are not very spread out at all. So this is an example of what I meant when I said the larger the standard deviation, the larger the spread of scores. And then the opposite's also true. The smaller the standard deviation, the smaller the spread of scores. Now let's take a look at how do we, now that we understand how to calculate measures of central tendency as well as dispersion, let's take a look at how we can do that in SPSS. Now there are three functions that can be used when you want to calculate descriptive statistics in SPSS. You can use frequencies, descriptives, or explore. So you go to descriptive statistics, from analyze you go to descriptive statistics, and then you can choose frequency, descriptives, or explore. Each of these have different features and different functions within, so I encourage you to explore them. However, for the most part, you can calculate measures of central tendency and dispersion using these three functions. Once you've calculated your descriptive statistics using either SPSS or calculating them by hand, you are then ready to report them. When you're reporting descriptive statistics, you can either use the name and say the mean is, or you can use notations. Here are the notations for different descriptive statistics. So for the mean, you can see that it's a capital M. For the standard deviation, you can see you can use a capital SD. I will note here that whenever you report notations per APA, they should be italicized. So it's really important to make sure that your statistics are italicized. So using the example distribution that we've been talking about, here's how I might report the descriptive statistics for that example. I would say that I have a convenient sample of undergraduate students. I enrolled in a statistics course, and as you can see here that N, which means the entire sample population, equals 5, and then I tell the reader that the course points ranged from 300 to 600. Now the measure of central tendency that I'm going to report is the mean, because I'm dealing with course points which are measured at the ratio level of measurement. So I report the mean, and then I also can then report the standard deviation. So this is an example of how I would report scores or specifically descriptive statistics using a narrative. Then here is an example of how I would report descriptive statistics using a table. Now let's say that instead of just having 5 students, undergrad students, to look at, I actually want to look at 2 sets of undergraduate students, students who take maybe a statistics course online and students who take it residentially. And I'm not just going to look at course points here, maybe I want to look at their scores on a test also. So here I have a descriptive statistics table disaggregated by the type of course. At the top, at the title, you'll note that the N, capital N, equals 10, because that's my entire sample population that I'm looking at. But then down below for online, I have N equals 5, and you'll note that that's a lowercase n because that indicates that's a group within the entire sample population. And you can see that I looked at 5 online students and 5 residential students. You can then also see in this table that we have the mean and the standard deviations listed. So this is an example of an APA formatted formatted table that could be used to report descriptive statistics. This then concludes part 1 of the tutorial on descriptive statistics. At this point, you should be able to define what a distribution is and explain what it is. You should be able to identify, define, and calculate measures of central tendency as well as dispersion. Know how to go about calculating descriptive statistics in SPSS and then also reporting them in APA format.